Well guys, it's finally happened. Some of you guys still ask me if I own the 2.8 liter Duramax Colorado, and I do. It's been about 4 years or so since I shot any major content on this truck. In the 4 years since 2020, really the only content that I've shot on this truck is simply maintenance. Because that's all frankly that I've had to do to this truck since I've owned it outside of warranty. I've shot, a couple videos on doing diff fluid and the trans fluid changes, transfer case fluid changes, stuff like that, fuel filters, oil changes, basic maintenance. Well, that changes today. The truck has an emissions problem, which if you go back to the video that I shot in 2020, that was what I knew was ultimately going to bite me in the butt with this thing, was going to be the emission system, and it has. So the truck currently has a P11DB NOx Sensor Performance code in it. So in this video, we're going to kind of go over a generic sort of diagnostic procedure on one of these NOx sensors. I'm going to give you some insight as to how the SCR system works, what the heck the SCR system is, how the NOx sensors work in an SCR system, and ultimately we're going to get my truck fixed here because I have to go on vacation 3 days from now and I need this truck running to drive, a couple thousand miles for vacation. So with all that in mind, let's get started here, and we're going to dive into what the heck we're actually talking about here with these modern emission controls in these diesel trucks. Now, before we start diving into theory and operation and sort of diagnosis of this particular problem that I have with these NOx sensors, I know that I'm going to have a bunch of comments down below that are going to say, just delete the truck. The reality of the situation is, deleting a emissions-equipped diesel truck is a federal crime. It is a felony. So do you really think that I'm going to record myself committing a felony and uploading it to YouTube? Probably not. So with that in mind, that is why I'm going to fix the truck. What a novel idea. That, coupled with the fact that that is everybody's standard answer, is just delete the truck. And I think part of the mentality behind just delete your truck is a fundamental lack of knowledge as to how these systems actually work. Can they be problematic? Sure. Does how the vehicle is driven play into its longevity? Absolutely. So now with that disclaimer sort of out of the way, we're going to take a dive into the SCR system. What it is, what it's ultimately responsible for, how does it actually work, and how does it relate to the problem that I'm having here. So if you have a basic understanding of how this SCR system works, you could kind of see how one of these sensors going bad would cause some sort of problem with the pollution controls in this truck. So SCR stands for Selective Catalyst Reduction. So what this system is partially responsible for is the reduction of NOx emissions. So the EGR system in a diesel vehicle reduces NOx emissions as well as the SCR system. Those two work in conjunction to greatly reduce the NOx output out of the tailpipe. Now, diesel vehicles by their very nature tend to get better fuel economy than gasoline engines. Their hydrocarbon emissions are much lower than gasoline engines, and their carbon monoxide emissions are much lower than gasoline engines. But the NOx emissions from a diesel vehicle tend to be much, much higher than what they would be in the equivalent gasoline engine. So what NOx is, NOx stands for Oxides of Nitrogen. It's typically abbreviated NOx. So like when I look up one of these sensors for this truck, it's a NOx sensor, NOx sensor. And ultimately what this stuff is, it is the visible smog that you can see in cities. It's responsible for acid rain, causing cancer, among, a bunch of other different things. It's nasty stuff. You don't want to be breathing it in. So this system is tasked with helping to reduce the NOx emissions out the end of the tailpipe. So now, in order to show you how this system actually functions, I figured the easiest way to do that would be to just to put my truck up in the air and sort of walk you guys through the system and what some of the components are, just so you have a basic understanding of how this system actually functions. Now, it really doesn't matter if you have a Duramax, a Power Stroke, or a Cummins. As far as I am personally aware, all of these systems pretty much operate all on the same principles. They all work generally the exact same way. I'm sure there's minor variations depending on the year, make, model that you're dealing with, but generally speaking, they're all kind of the same. So with all that in mind, let me show you what is actually going on here. So up at the engine, let me see if I can get my light on it here. You have NOx sensor number 1 up there. That actually reads the NOx emissions coming out of the engine. So the NOx emissions that are coming out of the engine are known. That information is sent to this little module here on the frame. This little module on the frame sends that information to 2 different computers. It sends it to a computer that controls the amount of DEF that's being injected, and it also sends it to the engine control module. So this right here is where the DEF is injected into the exhaust system. So moving back in the exhaust system, this big can that you see here is the SCR. This is the SCR catalyst. So the diesel exhaust fluid interacts with the SCR catalyst to reduce the NOx level. The reason that you want the upstream NOx level to be known is because you need to know how much DEF you need to inject into the exhaust in order to make the chemical reaction happen, in order to get the correct output out of the tailpipe. So coming out of the backside of the SCR catalyst is another NOx sensor. What this sensor does is it ultimately monitors the NOx level that is going out the end of the tailpipe. Hopefully all that makes sense for you guys. All of these systems, like I said, all kind of work on the exact same principles, but this is why diesel emissions on modern diesel trucks after 2011, as you can see, they're extremely complex. This is why people want to delete their trucks, because they don't have they don't want to deal with the sensors and the modules and the wiring that we're talking about, and they just want to rip all that stuff off and not have to worry about things like derate. So what derate is if the emissions level coming out of the end of the tailpipe is too high, it puts the truck into a scenario called derate. And what derate is where the truck actually limits its own top speed until the point that you basically can no longer drive the vehicle. So let's say, for example, I had an issue with the SCR catalyst or the DEF injector, and NOx sensor 2 was reading extremely high. That would put this truck into a situation called derate. What derate is where the top speed of the truck is limited for a certain mileage interval. So it starts out where it tells you you have 100 miles until you have a 65 mile an hour top speed. If you ride that out, it goes, all right, you have 100 miles until you have a 55 mile an hour top speed. If you ride that out, the top speed of the truck goes to 4 miles an hour. So that is why if you run a modern diesel truck out of DEF, that is why you cannot drive it, because the NOx level is going to be so high that it's not going to let you drive anywhere. So this is why people delete their trucks, because they don't want to deal with this kind of stuff. Like I said, I'm not an advocate for it, but I understand why people do it. When you're in the middle of nowhere and your top speed is limited to 4 miles an hour, yeah, that could be a big problem. Now my truck has a NOx Sensor 1 performance code in it. So let's take the truck for a drive and take a look at the data stream on my Banks iDash to just give you guys an idea of what this sensor is doing and why I have this code. So taking a look at the 2 sensor readings I have pulled up on my iDash, NOx Sensor 1 is on the top, and then NOx Sensor 2 after the SCR is on the bottom. Now, as I'm going up this hill by my house, I'm using very consistent throttle input here. And the reason that matters is NOx Sensor 1's reading is, generally speaking, very consistent with throttle input. So the more throttle input you give a vehicle, the higher the NOx emissions on a diesel are going to be. And as you can see, the reading on NOx Sensor 1 is absolutely jumping all over the place. So that is why I have this code that we're dealing with in this video. Let's see about getting this thing diagnosed. So guys, as far as being able to diagnose one of these sensors, I got a wiring diagram and started taking a look at, how I was going to actually test this sensor. And I realized very, very quickly that there isn't a whole lot for a DIYer to actually test here. And let me show you on this wiring diagram. So let me put it up on the screen. So if you take a look over on kind of in the middle of the screen here, the sensor that we're dealing with is the NOx sensor number 1. The power wire for NOx sensor number 1 is the violet and blue wire. If you trace back the violet and blue wire, this violet and blue wire sends power to two other sensors. So if I had some sort of power issue, chances are that I would have an issue with NOx sensor number 2 and the particulate matter sensor if I had a power problem like a blown fuse or something like that. It's the same story with the ground. All 3 of these sensors share the same ground. So the likelihood that I have a power or ground issue with this sensor is fairly slim. Now there is the possibility that I could have a broken wire past the junction point on the violet or blue or the black ground wire. That's completely within the realm of possibility, but the likelihood of that being the case, I'm going to tell you guys, is fairly slim, just based on the fact that if this sensor lost power, if you look at the other wires coming off this sensor, these are network wires. So this sensor actually sends a square wave signal to other modules here. So if I lost power, I'm going to have some sort of communication problem, and it would be shown as a communication code, not a sensor performance code. So this is why I was telling you guys, most DIYers really can't do a whole heck of a lot to test one of these NOx sensors. All the ones that I have seen, all the ones that I've seen wiring diagrams for, they all use some sort of multiplexing. And what multiplexing is the sensor sends out a square wave data signal. That square wave data signal is sent out over a network. The other sensors that are connected all send data on this same wire. So you're sending and receiving data over the same wire with multiple sensors using that exact same wire. This is exactly how telephones work. This is how the internet works. It's a principle called multiplexing. So you have multiple sensors sending and receiving data on the exact same wire. The only way that a DIYer or a mechanic can actually read this data stream coming off of these wires is with something called an oscilloscope. An oscilloscope will take that square wave signal and plot it in a line graph so you're able to actually read it. The issue that I have here is if I have an oscilloscope, which I don't, if I hooked it up to this sensor and the sensor is bad, I'm then seeing a bad signal on the oscilloscope, right? Well, the issue is I don't know what a quote-unquote good signal is. So the only way that I can get a good signal on an oscilloscope is swap to a known good sensor. Well, swapping to a known good sensor on this truck may very well fix my issue. So a quick and dirty way to be able to test one of these NOx sensors without an oscilloscope is actually with some glass cleaner. If you guys take the NOx sensor and unthread it from the exhaust, turn the key on to the vehicle, and be careful because the sensor is going to get hot because it has a heater in it. But once you have the sensor unthreaded from the exhaust and the key on, spray the sensor with some ammonia-based like glass cleaner. Anything with ammonia in it, it will actually cause the sensor to trigger, and you'll be able to see that change on your data stream if you have a scan tool. So that's going to be probably the quick and dirty way to sort of diagnose one of these sensors to kind of see if it's bad or not, or if it's capable of reading correctly or not, is simply take it out of the exhaust, spray it with some ammonia glass cleaner, and read your data stream and see what it looks like. Now, in the case of this truck, the probability of this sensor being bad, after looking at this wiring diagram, it's extremely high. Just based on the way that the data stream is behaving, it's pretty indicative of a bad sensor. So I'm going to go ahead and swap the sensor out because, like I said, I don't have an oscilloscope and I don't even have a good waveform to compare it with. So as I'm getting this sensor out of here, guys, there's a few things that you need to be looking at as you're pulling this thing out. First things first, you need to make sure you don't have any exhaust leaks, because an exhaust leak would then take outside air and pull that into the exhaust possibly and skew the numbers that you're seeing on the sensor. Now, some other things that could cause this sensor to be bad would be some sort of contamination. Could be water contamination, fuel contamination, or oil contamination. And
Unfortunately, all three of those things that I just listed, those are naturally occurring in a diesel exhaust system. A byproduct of the combustion process is water. The byproduct of the combustion process is soot. A byproduct of the combustion process, and just generally how the engine functions, is you're going to have some amount of oil going into the exhaust. So any one of those three things could have simply just contaminated this sensor and could be causing the issues that we're having here.
Okay, so I'm going to save you guys a bunch of time just listening to me swear. And what you really need to know about getting this sensor out is simply this. Most of these sensor removal sockets for O2 sensors, NOx sensors, whatever, that you're going to find on Amazon, these are absolute shit. And the reason that I say that is there's 4 different 22 millimeter sockets in this kit. This sensor is 22 millimeter. Every single one of these sockets, what would happen is when you put it on the sensor, the wall thickness of the socket is so thin, and because it has that slot in it, what would happen is when you go to remove the sensor to loosen it, the socket would stretch. So the slot in the socket would allow the socket to actually stretch and round off the sensor. Every one of these in this kit that would fit this sensor did that. It did not matter which one I tried. Long story short, 99.9% of the O2 sensor socket kits that you're going to find on Amazon, they're absolute crap. If you guys have a link to a good set that you can find on Amazon, Walmart, Home Depot, whatever, send me a link in an email. I will link it in this video for you guys. So what I ended up doing to get this thing out of here, it's going to come to no surprise to a bunch of you, is I cut the pigtail off the sensor. And if you come down here and look, I just have a standard impact socket, 1/2 inch ratchet, and guess what? It came out of there and loosened up without any issues. But unfortunately, because I cut the pigtail off of this, there's no way that I'm going to be able to save this sensor for the future if I ever need a spare or I want to clean it or anything like that. So at this point, it is what it is. I'm going to go ahead and install this new sensor.
So I'm sure some of you are going to ask what the end of this sensor looked like when I removed it. And honestly, yeah, there's some soot on it, but it really doesn't look all that bad visually. Who knows what's actually going on inside? I'd be curious if you could actually clean this thing. But again, since I cut the wire off, there isn't really a whole lot that I can do about cleaning it at this point. So now down underneath the truck, I need to remove the actual processing portion of this sensor. So this little microprocessor that is bolted to the frame receives the signal from the actual sensor in the exhaust pipe. It interprets that information from the sensor in the exhaust pipe and changes that signal into that square wave multiplex LIN bus signal that we were talking about earlier on in the video. So when you buy one of these sensors, typically they come with this box that I'm removing on the frame and the actual sensing portion of the sensor that goes in the exhaust pipe. You cannot buy these separately from one another from what I have seen. One other thing to note about sensors, guys, is you do not want to buy an aftermarket sensor here. The reason that I say that is if one of these sensors in this exhaust system happens to fail, it could put the truck into a derate situation where it's counting down the mileage and possibly limiting your top speed. Well, the difference in cost between a GM sensor and an aftermarket sensor may be $50 or $100, but the reality of the situation is, what's the cost of a towing bill and the inconvenience of having to change this sensor a second time? So just spend the money up front, buy the right sensor from the OEM, and if they've made any revisions to these sensors to help improve the reliability, you may benefit from some of that R&D research, hopefully. With that said, this sensor for this Colorado was roughly about $200. I've seen some Cummins stuff close to $400 or $500 for one of these NOx sensors, but it's kind of the game that you're playing when you buy a modern diesel vehicle. You know, this just comes with the territory. Like I said in the beginning, I knew something like this was going to bite me in the butt, and it took about 58,000 miles before it finally did.
So the last thing we have to do here to replace this sensor, quote unquote, correctly, is you actually have to get in a scan tool and reset the NOx sensor that you replaced. So I replaced NOx sensor number 1. So I need to go in the scan tool and reset the values for NOx sensor 1. What this is doing is you're telling the computer that the value that it's seeing right now at this moment, it's 0. So your old sensor may be calibrated slightly differently than your new one. So when you put the new sensor in, you have to tell it what 0 is, because otherwise it may be going off the calibration in the old sensor, which may skew your numbers. Okay, so in my scan tool, this is how I do it. You're just going to go to System Selection, Engine Control Module. Obviously, this is going to vary depending on the type of scanner you're dealing with, but you're going to go down to Special Functions, Reset Functions, and then scroll down the list until you see the NOx sensor you're dealing with. So right here, NOx sensor 1 reset right here. So you look there, the status is none. Hit reset, and there you go, status changed to reset. So there really isn't a whole lot to that, but at this point we should be good to go. So lights out, we'll take this thing for a test drive and see what happens here.
So what I have on the screen now is this 2 sensor readings side by side. So the left side is before I swap to the new sensor, and the right side is after. And taking a look, you can see NOx sensor 1, the reading that I have on the right side is a heck of a lot more consistent than what I have on the left. But the other thing that you'll notice here is the NOx sensor 2 readings are also much lower on the right than what they are on the left. And the reason for that is because the truck actually knows how much DEF to inject into that SCR catalyst to get the NOx readings as low as possible. So that was why the check engine light was on here, guys, is the emissions level, yes, it was slightly elevated, but ultimately the truck did not know how much DEF to put into that SCR catalyst in order to get the emissions down to where they needed to be.
So as you guys just saw, the sensor is ultimately what fixed this truck. And I'm happy to report I'm actually back from vacation at this point, where I drove this truck roughly 1,400 miles in the span of about 5 days. And on that trip, I had absolutely 0 issues with the truck. So at this point, the truck is largely, without any shadow of a doubt, the truck is in fact fixed. So the one thing that I can tell you guys is there's probably absolutely nothing that I could have done to prevent this failure. And the reason that I say that is, guys, I treat my fuel that goes in this truck every single time that I fill up. I treat the fuel with Standardine. If you guys aren't familiar about that stuff, it's similar to like Hot Shot Secret or Arch Oil or any of those other products on the market. Basically what it does is it increases the lubricity of the fuel, increases the cetane of the fuel, and increasing the cetane of diesel fuel is ultimately what promotes a cleaner burn in the combustion chamber. And the cleaner that you can burn the fuel, the less often you regen the DPF, the less buildup you have in the EGR system. It's just a good thing to do. There's just some trucks, guys, that are just more, it's just more common to have this sort of failure with. And that's kind of the case with one of these Colorados. I can't say that I've ever seen or read of a person that has 150, 200,000 miles on one of these Colorados with the diesel in it that hasn't had some sort of emissions problem, be it, you know, a DEF injector, one of the NOx sensors, a particulate matter sensor, or even, you know, like the DEF pump or a DEF heater or something like that. It's just the nature of what you're dealing with here. And as you guys saw, these systems are incredibly complex. And that is why I wanted to get some of this information out on the internet, to just kind of show how these systems work, just to have a counterpoint to the, you know, just delete it argument. So you guys can do whatever you want. My truck is staying emissions intact because I'm a little bit too public to be committing felonies and recording it to YouTube. So with all that in mind, guys, I will have links down in the description. First of all, to some ammonia-based glass cleaner if you guys want to try and diagnose one of these sensors yourself. Next thing is I'll have some common NOx sensor part numbers down there for you, whether you have a Ford, GM, Chrysler, whatever you have, some of the common part numbers that you see. As always, guys, if you guys like the video, hit like. If you want to see more content, go down and hit subscribe. Thanks for watching, guys.